Hello, let's look at this question. It's a question involving normal distribution, probability normal distribution. So the mass of chicken sold at a market are normally distributed, right? As you know that mass is a continuous random variable, right? It's a continuous random variable. It's a continuous because why? It's a mass, right, of a chicken. So it's normally distributed with mean of 1.5 kg and standard deviation 400 gram, right? So it's normally distributed. As you know that normal distribution is defined to having a mean and having a variance, right? In this question, it's already given you, right? It's already given the mean of the chicken, right? X is the mass, right? Is the mass, mass of a chicken, right? 1.5 kg, 1.5 kg, and 400 gram. Definitely, they must have a same unit, right? Same unit. So in this case, your mean is 1.5 kg, right? 1.5 kg. So your standard deviation, right? Standard deviation is given as 400 gram, right? 400 grams. So 400 gram is actually 0.4 kilogram, right? 0.4 kilogram. So means that you should write here as variance. Variance means standard deviation square, 0.4 square. So this is the normal distribution for this case. So a question asking us to find the probability that a chicken that chosen at random from the market weight less than 1.2 kg. Weight less than 1.2 kg. So very simple. This is the mass, right? The mass. So the mass is less than, is weight to be less than 1.2 kg. Alright, 1.2 kg. So you know that this you can using the normal distribution. So standardize the score. As you want the solving problem involving normal distribution, you have to standardize the score in order to using the statistical table. Formula will be x minus mean divided by the standard deviation, right? So this will become z less than 1.2 minus the mean. The mean will be 1.5 divided by 0.4, right? The standard deviation 0.4. So you are getting the value of which you were getting negative 0.75, right? Negative 0.75. So this distribution, right? If you forgot already, this distribution is actually because you already standardized the score, right? The score. So the z, the distribution for z, the normal distribution for z will be have a mean 0. So negative 0.75 is on the left of 0, right? It's this area, right? Less than negative 0.75. So if you know that this one is actually the same because they are symmetrical, right? Symmetrical, so is 0.75, the upper tail, right? So because your statistical table for matriculation is upper tail, so you can rewrite this to be Pz greater than 0.75, right? The area for this and the area for this are the same because they are symmetrical. So from this, you can find from a statistical table 0.75, right? 0.75 you can find from statistical table by looking at table 3, right? Table 3, so which is 0.75. 0.75 is this value here, right? 0.75. So 0.2266. 0.2266. This is a probability that the mass of the chicken weight less than 1.2 kg. Alright, as simple as that. Now go for part 2 of the question. Find the probability that a chicken chosen at random weight between 1.5 and 2.0 kg, right? It's between. So it means that the mass just now is less than 1.2. But now they're interested about the probability that how many percentage, okay, they want to know that the probability that the weight of the chicken between 1.5 kg and 2.0 0 kg, right? It's between these two, right? The range. So the mass here, you have, if you want to find the probability for a normal distribution, you have to change it, become a standardize the score, right? So means that I take 1.5 minus with 1.5, right? Mean divided by 0.4, and this you have take 2 minus with the mean, right? The mean will be 1.5 divided by 0.4, right? So you are getting the Z. So the value of Z is between 0, right? 0 up to 1.25, right? 1.25. So as you can using statistical table for this. So how, before using statistical table, you must know the distribution, right? The score Z here is from 0 up to 1.25. 0 is in the middle, right? In the middle. So which is divided this to 0.5 and 0.5. So Z is between 0 and 1.25. So means that it's between 0 and 1.25. This is the region, right? This is the region for the area, right, that we interested. So it's between 0 and 1.25. It's, as you know that 0, the mean, is this axis, is divide them to 0.5 and 0.5, the probability, right, to make up everything to be 1. So means for this case, I have to take Z more than 0, probability of Z greater than 0, minus away probability of Z greater than 1.25. The reason is, you look at it, this one is half of the distribution. Means that Pz more than 0 is supposed to be 0.5, right? This one you can find from statistical table. We take the area, Pz more than 0, everything, this area here, minus away this area, alright? Minus away this area, alright? This part, we minus away. So minus away, so we have to know the value from statistical table. 1.25 is actually 0.1056. Okay, 1056, which gives you the probability of 0.3944. Right, 0.3944. So very simple. So it's between 0 and 1.25, right? So 0 is at the middle. So if at the middle, the area here total will be 0.5, right? Half of the distribution, minus with greater than 1.25, this section here, right? You can find from statistical table with the value of 1.25, which gives you 0.1056, and this is your probability. Alright, okay, for part C of this question, they require us to find the probability that a chicken chosen at random find the mass exceeded by 10% of the chicken. Find the mass exceeded by 10% of the chicken. Okay, what is the meaning here? So, find the mass exceeded by 10% of the chicken. As you know that if you have a distribution, right? This is a distribution. So they want to find that, okay, let's say I already standardized the score. So you know that this part of the 10% exceeded by 10% of the chicken. So the weight of all the chicken total up, the probability of all the possibility, right? This everything will be 1, right? It will be 1. So what they mean by is 10%. 10%. The exceeded by 10% of the chicken. So it's the area where 0.1, right? Exceeded means more than. More than means that probability that sum of the chicken, which is more than a mass, is 0.1. That's the meaning. Exceeded by 10% of the chicken means that in the farm there are many chickens. All right. Every chickens have different weight, right? They want to know that the above 10%, which is more than a certain value of the mass, which is considered as 10% here, exceeded by 10%, right? This is the meaning here. So you should not draw it here, right? The value of M should not be here, all right? Why? Because this is 10% only, right? 10%, so it's in the right tail, yeah. So we have, before that, you have to convert this to become a standard score first. So Z greater than M minus with 1.5 divided by 0.4, which is 0.1. This value here is actually the value here, right? I can let this to be k, all right? I can just write this to be a k. So the value of k here will be m minus with 1.4 divided by 0.4, right? So means that this is the value of k here. K should be here. Why? It's only 10%, right? 10% of the chicken is exceed the mass m. Okay, I repeat again. 10% of the chicken, 10% of the chicken is exceeded this mass here, right? The mass. So that's why the question here is find the mass exceeded by 10% of the chicken. Means that a certain chicken that greater exceed the mass m is 10%. So how to find the value of k here? This is 0.1, right? And greater than. So you can using the statistical table. From statistical table, you find the value of 0.1. So you can find from table 3, but there are no value of 0.1 here, right? 0.1 here, there are no value of 0.1. There is 0.1020, 0.1003. So you have to round off. When you round off, means that the value is not so accurate, right? So that's why we have a special table, which is table 4, right? Table 4 at the end of the page of statistical table. So table of percentage point here. So if you find the value here, 0.1 is actually refer to the alpha here, 0.1. So where is 0.1? 0.1, the alpha. So the score Z will be 1.2816. 1.2816. So means that the value of K here is 1.2816 from the table 4. So now clearly I know that M minus 1.5, which is your K, is 1.2816. So definitely M minus 1.5 will be the same as 0.4 times with 1.2816. And the mass will be taking 0.4 times with 1.2816 plus with 1.5. Alright, so we're giving you the values of the mass here will be 2.013 kg. So to be more accurate, 2.013 kg, right? Which is greater than the mean value, right? Mean value 1.5. As you know that the mean value always has the before standardized become a standard score, the mean is 0. Before standardized, the normal distribution for this case here, the mass of chicken will be, the mean is 1.5 kg, right? So means that 10% of the chicken, 10%, the 10% here, 50%, this is 1.5 kg is the mean, right? It's the mean. Mean is at the central value, right? So it's 50% of the chicken is expected to more than 1.5 kg. And 10% is more than 2.013 kg, which is correct, right? It's greater than the mean. So, and it's 10%, all right? Contribute 10%. So the answer for the mass here will be refer to 2.013 kg. Or we can make a statement here, the mass exceeded by 10% of the chicken is 2.013 kg. Alright, okay, let's look at the next question. Alright, the final question here will be, in a day, right? In a day, 200 chickens are sold, right? 200 are sold. Means that, okay, it's considered that this is a number of sample here, right? Number of sample here, which have 200 chickens are sold. Estimate how many among this weight less than 1.2 kg, right? As you know that the probability from part A, right? From part A, you know that the probability of X less than 1.2 kg, just now you have calculated, you have getting the value of 0.2266, right? This is a probability that the weight is less than 1.2 kg for a chicken sold, right? So now they have 200 sample now. They have 200 sample now. So, and the probability of the weight of the chickens which is less than 1.2 kg is 0.2266, right? This is actually the percentage, all right? It's also considered as a probability, or we can say this is a percentage. Means that 22.66%, 22.66% of all the chicken is X less than 1.2 kg, right? Means that means that for the mass of the chicken to be less than 1.2 kg this is the percentage. Ini adalah peratus di mana ayam itu mempunyai jisim kurang daripada 1.2 kg. Alright. So of course definitely the estimate how many. So the number of chickens, right? The number of chickens sold, the number of chicken with mass less than 1.2 kg is or we say that equals to you just taking the 0.2266 the percentage multiply with all the chicken sold, right? The sample is 200, right? Means that we expected that the mean will be 200 multiplied with 0.2266. Then we can find the expected number of chicken which have a weight. Out of the 200, how many are weight less than 1.2 kg? I just take the percentage multiplied with the 200 lah. So definitely I will getting the value of around, right? After I multiply, getting the value of around 120. I round off here, alright? I round off here. So means that if you calculate, you're getting a decimal value. Oh, sorry, I'm calculate wrongly. So the value should not be 120. You take 0.2266 multiply with 200. So the value will be 45.32, right? If you calculate, getting 45.32. We just round off lah, okay? Estimate only, right? We just estimate. So there are 45 of them, right? 45 of them. So it means that 45 out of the 200 from the sample having the mass less than 1.2 kg. Very simple lah, okay? Just take the number of sample, multiply with the probability required. Alright, and then you will get the number of chicken that weight less than 1.2 kg. Alright, that's all for this video.